Yeah, she'd turn around and smack you. Let's keep it PG rated, please.
Keep it, if you keep it out of context, keep it out of context.
It is PG back in the 1970s. So technically, what are we supposed to do? We can't have something that Mike, I think it's best if you stop talking.
All right, any questions on the worksheet, which was a review?
Could you define all for us and or prove it to us?
All. Everything.
Okay, can you do that in a formal proof?
It's a definition. So by definition, all means everything.
I don't know where my
Well,
mouth.
then what does everything mean?
I don't know where.
Mr. Chartier, this only took 3 months for you to come up with that. Most geometry students realize a bit earlier that when the teacher says literally everything must be proved in class, there's always that one smart kid that takes that to the extreme and literally wants the teacher to prove everything.
Yeah.
It only took you 3 months.
No.
All right. Well, you guys already have all the answers on there so you can see them. But seriously, any questions? This was, I mean, chapter 1 and 2 should seem pretty darn simple now that we're almost in chapter 7, right? I will collect that here in a second. As promised, we're going to do a quick review on the other 2 chapters. So we did 1 and 2 yesterday. We're going to do 3 and 4. We just took the chapter 5 test. We're about to move on to chapter 6, and we'll start that on Monday. Just so you know, this is kind of a tentative schedule. We're supposed to take that test at some point. I'm supposed to get a briefing on it today. I don't know if it's going to be next week. It was supposed to happen in November. Well, there's only 2 weeks left of November, so I'm kind of anticipating that we're going to take that standardized test at some point here in the next 2 weeks. So it's no, you don't study for it. You just kind of show up, take a test. Yeah. Yes. All right, here we go. Homework tonight will be that second packet. It's quickly done. Now I'm gonna go do the review first.
No.
All right. Chapters 3 and 4 really involve this construction of 2 parallel lines cut by a transversal and all those angles. Chapter 4 was that introduction to triangles. All right, chapter 3. First thing we looked at was this construction right here, which was 2 lines cut by a third line. That third line, I always call it T for transversal. So a transversal is a line that intersects 2 or more. We have seen it intersect 3 lines before, a couple times. We did a couple proofs like that. But generally, it intersects 2. We also have to make the caveat that both of the 2 lines intersects are on the same plane. So they're not, you learners can't see this. If the 2 lines were like this, you could still intersect them. We're talking about the 2 lines are on the same plane. Okay. So we get lots and lots and lots of angles from that constructions. Lots and lots of angles. So give me some of those angles. Names. What do we got?
Interior.
Okay, which ones are the interiors?
3, 4, 5.
3, 4, 5, 6 are interior. Give me something else.
Exterior.
Okay, alternate interior would be
4, 5, 6, 3.
no. If you say alternate interior, then you got to tell me which ones are alternate interior. 4 and 5 and 6 and 3 would be alternate interior. Give me something else. Okay, lots of those. Which ones are they?
1, 5, 7, 3, 4, 8.
So same side, same position. Okay, what's left? Same side interior, Jenna says those would be 3, 5, 4, and 6. Anything else? Bless you. Thank you. Say again. Alternate exterior, we talked about it. Our book never talks about it. Which one would be the alternate exterior? 2 and 7, 1 and 8. Okay, I think we covered them all. So we got alternate interior, right? Those would be the ones in red and blue. We have a theorem that says that if you have alternate interior angles and the 2 lines H and K are parallel, then 3 and 6 and 4 and 5 are congruent. We proved that a long time ago. In fact, we've used this so many times in proofs. I mean, we used this when we were talking about parallelograms. Next one that we had was same side interior. We said they were same side interior are. Is Jenna the only one that remembers?
4 and 6.
Well, she said that, but what is the so what about same side interior? They are, Chris? They are not congruent.
Supplementary.
They are supplementary. But remember, this is a four. This is the four. Obviously, they're not supplementary here. But when the lines H and K are parallel, then same side interior angles are supplementary. And you can almost see the parallelogram that we can make right here. And obviously that's where we got the proof that same side, or that any two consecutive angles on a parallelogram are supplementary. All right, the next one we talked about, which was corresponding. Wes said this, corresponding angles are, they are congruent. What's up? Okay. Caleb?
Using the other
No,
No,
Caleb's not that smart. Come on.
I'm not thinking.
All right. So corresponding angles are congruent. This is the one we get the most of. This one kind of sneaks in now and then in geometry. We did it a lot in chapter 3, and occasionally we get corresponding angles congruent. We can make these challenging if we start throwing expressions in. All right. So these two are what? They are congruent because they are alternate interior. These two are because they are same side interior. So when you set these up tonight for homework, our worksheet generator thing says solve the one that's bold, right? So you'll see it there. So you said these are what? Supplementary or congruent? They are congruent, so you simply set up the equation, congruent. That means their values are equal. Do a little bit of geometry once again, or do a little bit of algebra. Once again, some of you are still having problems with this part right here. Remember, we have variables on both sides. You want your variables on one side. Always move the smaller of the two to make your life easier. If we subtract 23x from both sides, you get 0 on the left side, it's okay. Right? Add 5 to both sides, we see x is 5. This isn't the end, this is just the middle part. If you want to find out how big the angle is, by the way, these are congruent, you can throw it into either one, even though they're having you find for the upper right one. Since we know they're congruent, save yourself some time, just plug it into this one. 5 times 23 is what? 115, right? So 115. If you choose to plug it into the one that's bold, well, you get a bonus plan of doing some extra work, right? On the second one right here, you said these are supplementary. That means the two added together equal 180. Smarty pants, anybody want to say comments about this one before I solve the algebra?
If they are the same thing and they both equal 180, then you just can. So super easy equation.
Even simpler than that. I thought you were about to get it. It's 90, right? Yes. Now, this isn't always going to happen, right? So here's how you would do it if they were not equal. Well, if the sum of them are supplementary, well, then you set them up. This one plus this one equals 180. 2 and 2 are 4. 11 and 11 are 22. Subtract 4 from both sides. Divide by 22. You get x equals 8. We already know the answer is 90. But if you throw 8 in for either one of the x values right there, we get 88 plus 2, which is 90. Okay? That's pretty simple. The converse, we didn't do much of this, so I just need to remind you of this. So we had all these angles, alternate interior, same side interior, alternate exterior. We got vertical angles. We got linear pairs up there. The second part of chapter 3 was about proving that two lines are parallel. We had a theorem, a converse to every one that we've already had. So the converse to all of these say is that if you can show that alternate interior angles are congruent, or if you can show that corresponding angles are congruent, or if you can show that same side interior angles are supplementary, then you conclude that the two lines are parallel. So if you're asked to show that two lines are parallel, then show that any two corresponding angles are congruent, or show that any alternate interior angles are congruent, or show that the same side interior angles are supplementary. We had this fourth one. It's really rarely used, but if you can show, and it's kind of same side interior. If you can show that they're perpendicular to a third line, then you get to claim that as well too. That was our fourth one. We probably used it once on a homework and never saw it again. All right. We do have alternate exterior angles as well too. If you show that, then you're good to go. All right. And then lastly, if one line is parallel to a third line and the second line is parallel to the third line, and the two lines are parallel to each other. With the exception of 4, 5, and 6, pretty much you're always going to use 1, 2, and 3. Certainly, there are cases where 4, 5, and 6 come into play, But most of the time, you're dealing with 1, 2, or 3. Show me alternate interior, show me same side interior, or show me the corresponding angles congruent. So this looks like the same problem, right? If U is parallel to V, then what can you tell me about the question mark?
That's true. That's
It has to equal 76. If U is parallel to V, what can you tell me about question mark? Well, grinding to a halt here, trying to do the math in your head. It's got to be 67. So tonight for homework, when I hand you the packet, that's what they're asking for. They're saying, what value would make these two lines parallel, U and V? Well, then you know that then same side interior angles must be supplementary. Then you know that alternate interior angles must be congruent. Okay? So 76, and that one is 67, which you guys already got. Did with that, and immediately move to, well, we can make triangles. So just to insult your intelligence here, who remembers the 3 kinds of triangles by side? Danny, thank you for volunteering. Triangles by side measurements, give me the names of them. And I'm not looking for acute obtuse, I'm looking for by side measurements. There isn't nothing on the board because I'm asking you to tell me what I should put on the board. Okay, and then we're going to classify it by its length of its sides. There are 3, that's my hint. Okay, that would be by vertices. Okay, one starts with an S, one starts with an I, and one starts with an E.
That should be taken out loud.
Isosceles, thank you for listening.
I'm so sorry.
That leaves the S and the E. So isosceles triangle is a triangle that has 2 congruent sides. And then we got one that starts with an S and one that starts with an E. Okay.
Elastic.
All right. The 3, Danny, you better make sure you know this in your book, right? Somewhere in your book of truth, this should be written. So we got scaling triangles, we have isosceles triangles, that's where 2 sides are congruent. Who? Yeah, other class. I have no idea where they meet.
I think they're literally right.
Yeah, Miss Jambar.
Scaling isosceles, Danny, one last try for the E. This would be where 3 sides are the same. Equilateral. Okay, so those are the 3 types of triangles. Now, how would this come in play in geometry? Obviously, we have lots of theorems about this, but generally speaking, you might have a problem where it uses words. You have an equilateral triangle. So you're expected to take that bit of information and throw your 3 congruency symbols on there because you're told it's equilateral. Same thing with isosceles. We're not done with isosceles or equilateral. We're going to see them a lot for the rest of the book. All right, angle measurements. What do you got, Connor? Angle measurements. Obtuse, acute. There's 2 left. One starts with an R and one starts with an E. Think about angles. What kind of angles are they? Right triangle is one left, it's the one with the E. All the angles are the same. Equal, not lateral, but equal angular. All right, so we got acute, obtuse, right, and equal angular. By the way, we found out that equal angular triangles are also equilateral. So when you have an equilateral triangle, you have an equal angular, vice versa. Right, the converse of that as well too. All right, theorem 311. Bree, you probably remember this. What's 1 plus 2 plus 3?
2 plus 2 is 4.
And by that I mean measure of angle 1 plus the measure of angle 2 plus the measure of angle 3. How much? That's what theorem 311 says, is that the interior sum of the angles of a triangle are equal to 180 degrees. All right, 1, 2, we haven't done this one in a while. Bailey, this theorem is called the, where am I pointing to? I'm pointing to the inside or the outside of the triangle. Am I pointing to a side or an angle? So this is called the exterior angle of a triangle theorem. And it says, who remembers?
Oh, actually, I don't remember, but I know it. I kind of remember, but I don't know if it's
What's the relationship in Suspiciously, the ones in red are what we're going to be talking about. Suspiciously, I made them red. And remember what the exterior triangle angle theorem says?
So the two base angles add up to the exterior angle.
They're not called base,
No, I can't
but
remember the name.
legs.
of it. Legs or base or something like that. Legs.
it's a word that starts with a letter R. Remote.
Remote
So the two remote angles will be, what did you say?
will add up to the exterior.
Will add up to the exterior angle.
Interior
And remember, there's 3 exterior angles. So depending upon where you draw your exterior angle, depends upon which ones are the remote. It's not always the bottom 2 is equal to, well, actually it is. But I'm saying the ones that we designate as being remote are remote from the exterior angle. Okay? So this is basically, it says that 1 + 2 is equal to angle 4. Okay? You will see this. Okay? So it can be given to you in 2 different ways. They can have you find one of the remotes, or they can have you find the exterior angle. Madison, what's the setup for this one? Okay, so if you really wanted to be meticulous about it, you'd say that 107 is equal to question mark or x plus 84. Solve that equation. She just said, well, that's silly. I'm just going to subtract 84 from 107, which is the algebra that you would do.
Why would you write it like that? Like,
well, I'm just saying, if we want to take it from the theorem itself, because the theorem says that the 2 remote angles is equal to the exterior angle. So if I want to really write it out, and that, I'm not saying you have to. I'm just saying,
do that.
well, math teacher.
You would do such a terrible thing.
Okay.
Cells up there.
All right. I also said that you could solve for the exterior angle. So Bailey, what am I going to do? Say it one more time. So therefore you'd get, okay, she's got it. Yes? Okay, that's not too bad.
Yes, sir.
All right. Yes, I will insult your intelligence. We'll go around the room. Matt, the first polygon with the fewest number of sides is A. Okay. Danny, what's the next one? He just gave you one with 3 sides. That is called a what? Square is an example of this. Would be called a, that's an example of one.
I want to do one.
If triangle is what we call a 3-sided polygon, a 4-sided is called a, okay, quadrilateral. Okay, 5-side, Chris? 5. Pentagon? Chandler, 6? 8? 7? 7.
Octagon.
Sorry. Heptagon, 8.
Octagon.
9, you remember, Connor? 9? Nonagon, 10. She's flipping through her book of truth. She knows she wrote it down somewhere. Decagon, I didn't give you 11. Did I give you 12? N-gon would be anything. If you ever want to put, unless I specifically say, you know, it's got to be quadrilateral hexagon. But that was very good. Okay, so there are all the ones. Very good. Okay, 12 was dodecagon, if I remember right.
Dodecagon.
All right, think about this. We're going to get to those formulas that you can take any polygon. Polygons have interior and exterior angles. So the interior angles are on the inside, exterior angles are on the outside. They're formed by extending one of the sides. That's where you get your exterior angle from. Okay, you guys remember the 2 formulas? Okay. There's one formula to calculate the sum of all the interior angles. We've used it a couple times beyond this chapter. What is it? Of all of them. N minus 2 times 180. Well, technically there is a formula for exterior angles. However, we said that's silly. What's the sum for any polygon of all the exterior angles? 360. But they can make this problem more challenging, right? They can make this problem more challenging, right? The sum of all the interior angles is n minus 2 times 180. The sum of all the exterior angles is 360. What the questions generally ask is one of those angles. So if this is how you find all the interior angles, how do you find one of them? Take that formula and divide by divide by how many sides? Well, there's n sides. So this is really the formula that you generally use. Okay. If this is the sum of all the exterior angles, what's one of them? 360 divided by n. So these two right here, the bottom two, are generally the ones that you want to remember. Okay. Or you can remember these two and just use some common sense. Right? Sometimes common sense is not common. Yes, remember doing this? All right, you're going to see this on the review sheet today. All right, regular polygons, those are polygons where all the sides have the same measurements and all their angles have the same measurements. So if the question says, what's the sum of the interior angles of a pentagon, right? Well, let's see, interior angles would be n minus 2 times 180. So we plug that into the formula. How many sides? 5. So 5 minus 2 is 3. 3 times 180 is 540. Okay? What's the sum of all the exterior angles? Well, that was pretty simple, right? So the sum of all the exterior angles, there's nothing to do there. But usually what the question isn't like this or this, it's how much is one of them, right? So if the question says how much is the value of an, that means one interior angle, well then, well, you just calculated all the interior angles are 540, so you divide 540 by 5. Whatever that answer is the answer. Now, if that was the original question, then I wouldn't have used that formula. I would have used n minus 2, the quantity n minus 2 times 180 divided by n. Okay, and obviously its brother, twin sister would be what's the value of an exterior angle? Well, it's going to be 360 divided by how many sides? In this case, 360 divided by 5. So there's an example of how that's done. Okay. Usually they don't mess around and give you like variable expressions or something for this. They could. Usually that's complicated enough, they just give you values. Can you guys do these? Okay.
Yes, sir.
All right. Chapter 4, we started dealing with triangles. Remember, there are 5 ways to show that triangles are congruent. We've done this, and you know the Latin expression ad nauseum. Yes? You've done it till you're nauseous, right? That's not what it means, but it's close. Right, you've done it so many times, your head spin because you, okay, I got this, right? Just make sure. I have an e-learner that I was tutoring the other day, and they were still in the honors class, and they're still struggling on this stuff, right? You shouldn't be struggling on this because we've done it so many times. Obviously, you are. I can help you. But this isn't going to end. I told you, all high school proofs or all high school geometry involves you make 2 triangles, show they're congruent, you call CP, okay? So, are the triangles congruent? You got 5 ways. Only one of them deals with right triangles, right? Only one of them, okay? So, if you have a right triangle, you can certainly use any of the other 4, but generally speaking, it makes it easier because we have, this is the angle side one, right? There is no angle side, but technically hypotenuse leg is angle side because hypotenuse leg are two sides, a right triangle, so it's got right angles. We just don't call it angle side, we call it hypotenuse leg. I'm not sure if anyone really changed that from angle side to hypotenuse leg for the reason of the word itself, but that's my explanation. All right, an isosceles triangle, remember that's a triangle where you have 2 sides are congruent. We got a whole bunch of stuff from this. If the 2 sides are congruent, what can you tell me about the 2 base angles? This is what you were trying to say earlier. What can you say about the 2 base angles of an isosceles triangle? They are congruent. So just remember the names. We say the vertex angle, that's the angle between or the angle formed from the 2 congruent sides. The 2 congruent sides are called the legs. And obviously the 3rd side is called the base. And so what we say is the base angles of an isosceles triangle are congruent. This is Theorem 4.1. Theorem 4.1 says that the base angles of an isosceles triangle are congruent. We do have the converse to this as well too. If you can show me that 2 angles of a triangle are congruent, the sides opposite it are congruent as well too. All right. Couple definitions. If I place a point halfway down BC, we call that point midpoint. And if we connect it to the opposite vertex, we call that line we drew, right? We call that anybody? Well, it may or may not be an angle bisect. We haven't actually seen that yet. we call it a median, right? The median, that red portion right there is the median. A median is where you connect any vertex to the midpoint of the opposite side of a triangle. We call that a median. There's also a median of a trapezoid, different meaning, right? So you got to make sure when it says median, you know if you're dealing with trapezoid in this case, or you're dealing with triangles. All right. So here are the three ways that that could look, right? Basically, the median. What is it good for? Well, we found a couple uses for it. The second construction we did in chapter 4 was it's not the median, but you connect a vertex to the opposite side and you make a right angle. What do we call this red line right here? It could be, but we don't know yet if it's perpendicular, or we don't know yet if it's a bisector, but it's certainly a perpendicular. It starts with an A. Clearly, this was one not memorable, right? This is called an altitude. So an altitude for a triangle is when you connect a vertex to the opposite side, you make a right angle. Okay? All right, so those are the three constructions. Now, this is for acute triangles. It looks very different for obtuse triangles. This is the one where the altitude is actually off of the triangle itself. Okay? And that was it. Right? That was all chapters. Now, granted, the big thing in chapter 4 was the SSS, SAS, AAS, and hypotenuse leg, and whatever the one, ASA, those 5 things. All right, so your review sheet is as follows. As always, answers on the back. He's passing this out. I'll come around and collect your homework. And in the remainder of the class period, you shall do your worksheet. Homework. 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 Chris. Homework. It does, doesn't it? You know why? Because in period 1, I handed it out to Chris's brother. So, Chris.
Wait, I don't remember.
I think you'll survive.
Looks like one of Jasmine's Oh, I forget. I don't. No.
Is jasmine a food or is it just a smell?
Jasmine's a rice. Jasmine's a meat.
Yeah, jasmine rice.
I know that, but I'm saying, and I've heard of jasmine
For
rice.
the longest time, I had my Steam name Rice Operator, and I had a picture of jasmine rice as my profile.
Sorry.
I'm gonna write my
Where's your
name.
homework? Okay. Homework again.
We're doing
James, I got your homework.
Yeah.
Extras, this is, I'm doing the honors class. We're getting the same homework tonight. All right, do I have any e-learners present? I do not. So I'm going to end this lesson here. It is already online, the worksheets. Make sure that's done. We'll start new lesson on Monday.